Hi, my name is Luyren, and here's a quick Stencyl tip. Know the attribute types. This will be a quick overview of all the attribute types you can use in Stencyl. By using attributes, you can individually customize your behaviors for actors and scenes, store and manipulate values, and much more. I will show basic usage, how to set their values, and how they appear on Stencyl's interface. If you need more information about behaviors, my Why You Should Use Behaviors video got you covered. I recommend you read the Stenzylpedia articles on attributes and attribute types, as well as the available articles on each type for more in-depth information. Before we begin, a huge thank you to a fellow musician and game developer, Leon the Artist, who provided the music you'll be listening throughout this quick tip. I'd also like to thank Mort, artist and game developer. He helped me get started on making these tutorial videos and provided me with valuable feedback. His tutorials on pixel art and art in general are great, and I highly recommend you watch them. Links to check out their stuff will be in the description below. That's it for introductions, let's get started! To create an attribute, go to the Attributes button tab in your behavior or actor and scene events, then click Add Attribute. Give it a name, select its type, and decide if it is hidden or not. You can later change the hidden state by clicking here or here. You can give your attribute a description, useful to know what it's used for. And you can set a default value, depending on its type. Default values only apply to non-hidden attributes. They cannot give an initial value to a hidden attribute. Since all the attributes in actors and scene events are always hidden, default values do not work on them, only in behaviors. Non-hidden attributes can have their value set individually for each actor or scene. Blocks for your attribute will appear in the Attributes section of the palette. Getters will return the attribute's value, used when you want to do something with the value of that attribute. Setters allow you to change the value of the attribute from within the code. When we say a block returns a value, it means it will use whatever value it is storing. In this example, if the value of the attribute speed is set to 5, using its getter block will return that number 5. For all attribute types, you can check if they have a value or not by using the hasValue block under Attributes, Functions in the palette. There's also a block to clear an attribute's value. I'll go over instances where they are useful later on. Now, let's check each attribute type. Actor attribute. This refers to a specific actor, either created during gameplay or placed on the scene designer. When not hidden, you can select an actor on the scene as its value. On actor behaviors, you can only set non-hidden actor attributes by using instance customization. When you want to set it to an actor created during gameplay, you immediately set the attribute to Last Created Actor, after creating your actor. You can also set it through collision events. You can set it using the loops for actors on screen, actors inside region, actors of type, and actors of group. All of these are ways to reference actors. In any of the blocks in which you must specify an actor, you can use an actor attribute block in it. That way, the actor stored in that attribute will receive the effects of your block. If you try to do anything with an actor attribute that has no value or isn't alive, your game will crash with a null reference error, known as the 1009 error. That's because there is no actor to move or change position, for example. To avoid that, I recommend you check if the actor attribute has a value and if it is alive before doing anything with it. And here is a quick use case. Create an actor and kill it after some time has passed. Actor group attribute. This refers to actor groups, configured under Settings, Groups. I go in detail about actor groups in my Know Your Collisions video. When not hidden, you select an actor group as its value. You can set actor group attributes to the group of an existing actor, either by referencing an actor attribute or any of the methods I described to reference actors. If you use the sText block, you can check for actor groups based on their names. You can use actor groups to check for collisions with actors of specific groups, or execute code based on the group of a given actor. You can also specifically check for the group of the colliding shape, which is useful for actors with multiple collision boxes. Actor type attribute. This refers to actor types. While actor attributes refer to individual actors on the scene, actor types are the ones you create under Resources Actor Types. They are the templates for each actor in your scenes. When not hidden, you select an actor type as its value. Just like actor groups, you can also set it to the type of an existing actor, through attributes or other reference methods. And you can also compare the name of an actor type attribute by using the sText block. You can perform specific checks for actor types just like with actor groups. But the most common use of actor type attributes is to create actors. One last thing, you can set an actor type attribute in your code by using the actor type with name block and typing in the name of your actor type. You can also retrieve the name from a text, list, or map attribute. Animation attributes. This refers to an animation of an actor. When not hidden, you select an animation of the actor with this behavior. On scene behaviors, non-hidden animations will not appear in the Behaviors tab. Animations can be set directly using their names, set to the current animation of an actor, and you can also check for their names directly. Its most common use is to set the animation of an actor. Anything attributes. These are wildcard attributes. It doesn't appear in the Behaviors tab if not hidden. As for its value, it can be, as its name implies, anything. You can set this to scenes, actors, sounds, fonts, lists, literally anything. One use I found for it is storing actor effects under Actors, Effects on the palette. Boolean attributes. These are used for true and false statements. When not hidden, you set a Boolean attribute to true by checking the checkbox, and false when you leave it unchecked. All the blocks that act as booleans have pointy ends. For example, the Boolean and comparison blocks under Flow on the palette. You set Boolean attributes to any of those blocks. If you place a Boolean directly in an if statement, it checks if that attribute is true. If you place it inside the not block, it will check if the Boolean is false. The not block can also be used when setting the value of a Boolean attribute. I recommend you give your booleans descriptive names, so that when you read the blocks out loud, it makes sense. For example, if not stunned. You can convert text and other values into booleans by using the asBoolean block. A text attribute set to true or false will become booleans with those values. Number attributes set to 1 will be converted to true, while any other number will be converted to false. Booleans are used to control the state of your behavior. You can also use them to have different options within your behavior. Collision shape attributes. These refer to collision shapes of your actor. They don't appear in the Behaviors tab if set to Not Hidden. You set its value with the blocks under Actors, Properties, Collision Shapes in the palette. The use of this attribute is confined to these blocks. I haven't found a use case for this attribute type yet, so leave a comment below if you use them for anything. Color attribute. This refers to a color. When not hidden, Stencyl opens a color picker for you to set its value. You can also set it with the red, green, and blue value numbers for the color you want, by using the block under Images, Change Images in the palette. Colors can be used with the drawing blocks, Image API, and actor effects, for example. Control attribute. This refers to a control in your game, configured under Settings, Controls. When not hidden, you set the attribute to one of the configured controls. They are used for player input. As well as having different actors using different controls, this attribute type can be used as a centralized reference point for all your controls. For example, if later in development you decide to change your control in the behavior, you can simply change this attribute, and all references to it will change as well. Font attribute. This refers to a font in your game, created under Resources, Fonts. When not hidden, you select one of these fonts as the value of the attribute. Fonts can be used with the Drawing and Image API blocks. Image and Image Instance attributes. This refers to images used with the Image API blocks under Images in the palette. They do not appear in the Behaviors tab when not hidden. Images work like canvases, which you can do a bunch of stuff with, and image instances are individual instances of the images. Images are like actor types, and image instances are like the individual actors. I'll have a video on the Image API in the future explaining this in more detail. For now, there's a Stencylpedia article on this subject that you can read. Joint attribute. This refers to joints, created in the Scene Designer. Joints are used to connect actors. By right-clicking the Joints button, you can select stick, hinge, and sliding joints. Stick joints connect two actors, while hinge and sliding joints connect the actor to the background. You can change the properties of hinge and sliding joints by setting the working mode to Joints, clicking them, then going to the Inspector tab. When not hidden, you select a joint created in the Scene Designer. For actor behaviors, you can only configure non-hidden joint attributes through instance customization. To make proper use of joint attributes, I recommend using the Joints extension, which can be found here. List and map attributes. Lists organize values in order, and maps organize values using specific keys. A list example is a ranking list, with the order of the competitors representing first place, second place, etc. A map example would be an attendance list, in which you assign a present or absent value to individual names. When not hidden, you can add and remove values to them, but limited to text and numbers. On maps, you have to specify a key, and each key must be unique. You can also import entire lists and maps from a text file. For lists, each line corresponds to an entry. For maps, add the name of the key, the equal sign, and the value of that key. When working with them in behaviors, they can store literally any attribute type, from text and numbers to colors, actors, scenes, and images. To interact with them, use the blocks under Attributes, Lists, and Maps. Lists and maps have a variety of uses and can greatly expand the versatility of your code. I'll have a video on them specifically in the future with an in-depth explanation, but for now, there are Stencylpedia articles you can reference. Number attributes. This refers to numbers. When not hidden, you type in the number you want as its value. You can interact with numbers by using the blocks under Numbers and Text, Math, and Trig/Exponent. There are a few blocks worth a special mention. The random number blocks are used to generate a random number. Useful if you want to add randomness into your game. Integers refer to whole numbers, like 1, 2, 3, etc. Float, or floating points, have decimal points in it, like 1.1 or 3.14. The The increment-decrement number block is useful to modify a number attribute, a good one to use often. The asNumber block converts booleans and text into numbers. Booleans will become 0 and 1 for false and true respectively. And if your text only has numbers, it will cover them appropriately. Be careful with text conversion though. If you try to convert a text with letters in it, you'll get not a number, and have weird results in your game. Another block specific to number attributes is the change number block under Attributes, Functions. This lets you change a number attribute to a target number over the specified amount of time in seconds, using one of many tween options. You can also stop a number mid-change using the Stop Changing block. Numbers are used to store information such as the player's current health or money. They are also used if you want to have character upgrades. In this example, a number attribute can be used to set the actor's walking speed. You can simply modify the number attribute to have the actor walk slower or faster. Region attribute. This refers to regions. They can be created via blocks, or in the scene designer. You can right-click the region button to create circle or polygon regions as well. Note that regions are different from terrains. The region attribute and blocks work specifically on regions, which acts as sensors. Terrains are the equivalent of solid regions. Regions can detect actors inside them, with blocks and events specifically for that. When not hidden, you select a region you created in the scene designer. On actor behaviors, you need instance customization to do that. Note that you cannot select a terrain this way, only regions. The blocks used to manipulate regions can be found under Scenes, Regions in the palette. Regions are useful to execute code when the actor enters or leaves them, for example a range in which enemies can detect the player, or an area in which they take constant damage while inside it. Scene attribute. This refers to scenes in your games, created under Resources, Scenes. When not hidden, you select a scene in your game. Blocks for scene transitions can be found under Scenes, Game Flow in the palette. You can also set a scene attribute by the scene's name, using this block. This attribute is used for scene transitions. You can have a behavior in which you just change the value of the scene attribute to go to different scenes. By using the scene with name block and combining it with lists, you can also switch to scenes based on their names in a list, like so. Shader attribute. Shaders are visual effects applied to the entire screen, like filters in a photo. They cannot be set in the Behaviors tab when not hidden. Shader blocks are located under Scenes, Shaders on the palette. You can code your own shaders using the OpenGL shading language if you have the knowledge for that. To use the Change Shader property blocks, which allows you to modify the existing shaders, refer to the Stencylpedia article. Sound attribute refers to sounds in your games created under Resources, Sounds. Use the blocks under Sounds on the palette to interact with them. When not hidden, you can select a sound in your game. You can also set sounds based on their names by using the Sound with Name block. Sound attributes are only used for playing or looping the sound. To pause, stop, and other changes, you must refer to a specific sound channel. Stencyl has 32 sound channels available, numbered from 0 to 31. You can use number attributes to reference specific sound channels. If you use the playback blocks, your sound will play at the next available channel, meaning the next channel that's not playing any sound. If you use the channels blocks, the sound will play at a specified channel, stopping anything that was playing in it previously. Text attribute. This refers to text, also known as strings. When not hidden, you can type in the value of your text. You can change your text attributes into drop-down menus on the Behaviors tab, which can be useful if you want to limit your attributes' possible values. To do that, select your attribute and click Drop-down. In here, each line is a drop-down entry. Type in the text you want for the drop-down menu, the equal sign, and the actual value of the attribute. In this example, fire is displayed in the drop-down, and when you select it, the attribute's value will be set to 0. Same here, ice on the drop-down display, cold as its value. You can also create a drop-down with all your game attributes. To do that, set it to curly brace, game attributes in all caps, close curly brace. To interact with text in your code, use the blocks under Numbers and Text, Text in the palette. An important thing to keep in mind is that when comparing texts with numbers, it must always be between the same type of values. If you want to check if your text is equal a number, either convert your text into a number or convert your number into a text. Like numbers, texts are useful to store information and to create options within your behaviors. They are also useful to display text on screen. One very useful thing you can do with text is split them, either into words or using a separator. When you use these blocks, your text becomes a list, in which you can use all the access list blocks. This will be covered in more detail in a future video. All of these blue attribute blocks I've been showcasing are not saved when using the save game block. Neither do they persist through scene transitions or scene reloads. That means if you change or reload scenes, or load your game, their values will be reset to whatever you had them configured to initially. For attributes that persist through scene transitions and that can be saved, you want to use game attributes. They are created under Settings, Attributes, and appear under Game Attributes in the palette. Game attributes are limited to numbers, text, booleans, lists, and maps, and are configured just like attributes of those types. If there is a type that you want to store in a game attribute not available here, store its name instead, and then convert it to the appropriate type when you load, using the actor type with name, sound with name, and scene with name blocks. If you try to store in a game attribute any type that's not one of these, your game may crash when you use the save block, so be careful. The last topic I want to cover are dynamic values. They work just like attributes and game attributes, but you don't need to create them beforehand. They are created as soon as you set their values within the code. They work like the anything attribute, and you can store anything in them. Actor values are the same across all the behaviors for your actor, meaning they are simpler to retrieve. They are under Actors, Properties. For game attributes, they are under Game Attributes, Dynamic Game Attributes. The saving limitations described in the Game Attributes section still apply here, so be careful. You can use the dynamic game attribute blocks to reference your regular game attributes, meaning these two blocks would return the value from the same game attribute. With game attributes and dynamic values covered, I must mention that there is a way to save the blue attributes and actor values blocks, covering both saving the game and scene transitions. In both my cutscene resource pack and miscellaneous behaviors pack, there is a behavior called Save Status. In it, you select a single map game attribute or dynamic game attribute to store the information for all your actors. A key specific to the actor you are configuring, and then all the attributes and actor values you want to save for your actor. The next time this actor is created, all this information is loaded. the speed and layer of your actor can also be saved. That's it for this quick tip. Hopefully, you now have a better understanding of the available attribute types to use in your code, and learn some extra tidbits about Stencyl's interface. I'll leave links in the description if you want to learn more about Stencyl, my itch.io page to get the Stencyl resources I've made, and to my Twitter if you want updates on what I'm currently working on. I'll also leave links to Leon the artist who provided music for this video, and Mort, who's been helping me with video making tips. Leave a comment if there are any Stencyl topic you want me to cover. Suggestions are always welcome. Thank you so much for watching.